We have certain triangles where the sine law doesn't work. In this case, we will use what's called the cosine law. Again, this is triangles that don't have a 90-degree angle in it. So I'm going to show you where the cosine law comes from. Just watch and pay attention. This just proves where this formula on your formula sheet comes from. I hate just giving you a formula. So if we draw a vertical line from C to A, and let's call this H. I know it's vertical because it's coming at a 90-degree angle. And we apply the Pythagorean theorem, we can get what h squared is. So h squared is one of the legs. I don't know if your book has b in the wrong spot, so let's move b to the right spot. C, of course, is from this whole entire side. So if I call this little guy here x, this section will be c minus x. Does that make sense? If I add c minus x and x together, I get c. So if I want to know what h squared is, I look at this small or smaller triangle, and I see, using Pythagorean theorem, here's my 90-degree angle, that h squared would be the hypotenuse, which is b squared, minus the c minus x squared. It sounds really complicated. Okay, and then if I look at the other triangle here, with this 90 degree, h is the same h, but this time if I look at it from that side, h squared would be a squared minus x squared. So because h squares are both the same, we can actually set those two equations equal to each other. So first things first, I need to FOIL this. So some people might have a problem with the FOIL written like that, so I'm going to write it out like this. So I'm just going to write out a squared minus x squared equals b squared. I'm going to leave the minus with a bracket, and I'm going to multiply out c minus x squared. So c times c, the first in FOIL, is c squared. Outer I get minus cx, inner I get minus cx. So that means I get two of them. And last I get plus x squared. So now the next step, I'm going to actually get rid of the brackets. A squared minus x squared equals b squared minus c squared plus 2cx minus x squared. So if I move the x squares over to the other side, guess what happens? They vanish. Nice. So then I get a squared equals b squared minus c squared plus 2cx. Wow, what the heck is x? Well, let's go back to this original question here. X was this little side here. And if I use, let's say, A here, sorry, use this angle B, then cos B would be x over A, adjacent over buttons. If I cross multiply that over, x would actually equal A cos B. So I'm going to replace x with A cos B. So a squared equals b squared minus c squared plus 2c. Instead of the x now, I'm going to have cos A times cos B. Now, if I rearrange this, and I actually move everything over to the other side and get what b squared is, meaning I'm going to move this and this over, I'm going to get, well, before I do that, I'm going to simplify this actually. So a squared equals b squared minus c squared plus 2ac cos b. So you'll see some formulas coming up. It doesn't necessarily look like that, but if I move this b over and this b over, a squared over, I will get the rearrangement of b squared equals a squared plus c squared minus 2ac cos b. And if you don't get what I just did, essentially, I know I switched them around or whatever, but if I switch them all around, I actually got all negatives. So this became negative b squared equals negative a squared minus c squared plus 2ac cos b. That's too many negatives, so that's why I switched all the signs there. So on your formula sheet, you're only given one of the formulas, but really you can see that all the formulas are basically the same. They just have the letters rearranged. So of course this is little a here, just so you know. So the capital letters, of course, are the angles again, and the little a's are the sides. So when do you use cosine law? Well, that's when you're given, we'll see in a second here. Before we do that, let's do this example here. It says, rewrite the cosine law for side t of STR. So if I want to know what side t is equal to, that would be t squared equals, then I want the remainder to follow. So all you have to do is follow the a and the b and the c of the formula and just rearrange it. So let's pretend t is my a. So wherever I see an a, I'm putting a t, and then a big T, of course, for cos a. So that would mean this is s squared plus r squared minus 2sr cos big T. So all I'm doing is replacing letters. They're all variables. They don't really mean A has to be A. It's just A has to be the side that's opposite the angle A. So here's the two cases that you actually use a cosine law. The first is when you're given a side, then the immediate adjacent angle, then the immediate adjacent side again. So here's my side, here's my angle, here's my side. So when we have that set up, we're ready for the cosine law. So again, it doesn't matter what letters they are. We're trying to find the measure A. Find the measure of side A. That's this little thing here. And angles B and C. So we don't know what those two are. So if I want to find A, I'm going to use the formula a squared equals b squared plus c squared minus 2bc cos big A. From my formula sheet. I'm going to plug in what I know. This, of course, is little b. This, of course, is little c. So a squared equals 42 squared plus 51 squared minus 2 times 42 times 51 cos 39 degrees. Now, these brackets right here just mean multiply. So if I punch that into my calculator, I'll give you a second to punch it in. We're going to do this all in one fall swoop. 42 squared, you should be able to find your square button, plus 51 squared, again with your square button. Subtract 2 times 42 times 51 cos 39. So what do you get when you get a squared? I'm just going to write roughly what it is. 1035.706.701 blah, blah, blah. Okay, so how do we go from a squared to a? Of course, we square root it. So we're going to do it to the nearest tenth, and that would be 32.2 centimeters. So does everybody agree the sine law is way easier than the cosine law? So if I want to find angle B now, do you see I have a known pair? I now have this known as 32.2, and I have this pair right here, so that's how I'm going to solve the rest. So sine of 39 degrees over 32.2 equals sine B over 42. So I'm going to do a cross multiply and then inverse sine. I'll give you a moment to get that. what do we get? 55.2 degrees. So how do I find the third angle? Well, that's pretty easy. We know that a triangle has to add up to 180. We know that one of the angles is 39. So if we take 180 degrees, subtract 39, and subtract 55.2, we will get that angle C is now 85.8 degrees. So note, when solving the second angle in side angle side triangles, always find the angle opposite the shorter of the two given sides, since the angle will always be acute. The problem being is the ambiguous case. We don't want to set ourselves up for an ambiguous case. So that's why I chose to use the 42 centimeter side here rather than trying to solve what C was first. So watch always for that. Okay, so the second case is side, side, side. So that's when we have all three sides given. So, and no given angles. When solving for the angle, we have this setup. It's just a rearrangement of the formula. It's already put on your formula sheet, so it's not a big deal. We don't even have to memorize it. So it's just a matter of knowing that the last step will now be doing the inverse cos. So if I want to find angle E is right here. This would be my little e. F is, of course, opposite big F, and little d is opposite that. So I'm going to rewrite the formula in terms of E, just so we have it. So cos big E is equal to d squared plus f squared minus e squared divided by 2bf. And you might say, how do I know that's the formula? Because the A should match and the other two just kind of come into play afterwards, right? So cos E equals 32 squared plus 21 squared minus 41 squared all over 2 times 32 times 21. Watch when you punch this into your calculator that this is the entire top divided by the entire bottom. Lots of brackets there. Okay, when you punch this in, I'll give you a second to punch this in all in one fall swoop and tell me what cos E actually equals. And I'll write it all out. Watch your brackets. You should get negative 0.1607, blah, blah, blah. If you don't get this, keep on attempting to punch this into your calculator. You need to know how to punch this into your calculator to get the correct answer. If you're not getting that cos E is equal to that, it probably has something to do with your brackets. The other thing is you can completely find what the numerator is equal to, and then the denominator is equal to, and then divide the two last step. Of course, the final last step is inverse cosine cos E, and you get approximately 99.2 degrees for E. Okay, so the next example is solving the triangle. Solving the triangle means I need to know all the angles and all the sides. So when solving SSS triangles, always solve for the largest angle first across from the longest side. This will take care of an obtuse angle if present. So that means we are going to be solving for angle A first. So here's my little A, here's my little C, here's my little B, and I will write it out. Cos A is equal to B squared plus C squared minus A squared divided by 2BC cos big A. So cos A, in my case, is equal to 7 squared plus 9 squared minus 14 squared divided by 2 times 7 times 9. I will repeat, make sure you use these brackets at the top, brackets at the bottom. I'm not going to show my intermediate step. I am just going to give you the angle. You need to punch this in and make sure you can get, in the last step after you inverse cos it, approximately 121.6 degrees. So that means this is 121.6 degrees here. So after I'm done that, I can figure out another angle by using the sine law. Now, I did say that the second angle in a side angle side you have to watch out for, but you don't have to watch out for in side, 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 except that you should be solving the largest angle first, which we did. So after that, let's just go with this one now. So sine B over 7 is equal to sine of 121.6 degrees over 14. Do a little cross multiply, inverse sine. B, again, you need to punch this in. You can pause the video. You need to figure out how to punch this in and get this answer. So just copying this down is not acceptable enough. You have to be able to know how to get this answer. So keep on plugging away until you get 25.2. Again, you're going to cross multiply the 7 over. Last step, inverse sine it, and you'll get B to be 25.2. Okay, so after I get B is 25.2 and A is 121.6, how do I get angle C? Well, that would be 33.2. How do I get that? Well, that's just 180, subtract 121.6, subtract 25.2. So the last thing we want to do is, again, when we're solving triangles, always, of course, check for right triangles, because that means it's easy. We're going to use the trig ratio, SOHCAHTOA, and Pythagorean theorem. The next easiest thing is known pairs. Known pairs means I can use the sine law. And of course, when you have the donkey theorem, which spells a really bad word here, that means you need to watch out for the ambiguous case. And if none of these are possibilities, we are going to use the cosine law, which is involved in a side angle side and a side side side.